Manolis Kellis is professor of computer science at MIT. He's the head of the MIT Computational Biology Group, associate member of the Broad Institute at MIT and Harvard, and principal investigator at CSAIL. Thanks for being here.
Thank you for having me. I'm so excited to talk.
We're doing it on video, kind of a last minute thing, but we just rolled with it.
Sounds like a plan.
Here we are in your office, right?
There you go.
So let's rewind for a minute. So a little more than 2 years ago, I think it was like Thanksgiving-ish, right, of 2022, AI rolls out ChatGPT. And people are all, of course, at that point, abuzz about AI. When you look back on the last 2 years, which has been like this whirlwind 2 years, right? What do you think in terms of the progress you've seen?
I think AI has been progressing at a tremendous pace for the last many decades.
Yeah.
However, something fundamentally new happened in the mid-2010s. And that fundamentally new thing is representation learning. The concept that machines are no longer learning from raw data, but instead they're expanding representations from that raw data. They're learning at a more abstract level. And then suddenly, instead of focusing on pixels, you focus on objects and shapes. Instead of focusing on individual characters or words, you focus on ideas. And that revolution is basically what led to this extraordinary progress that we've seen in the last 2 years. So that revolution started initially with AlexNet and ImageNet and all of the representation learning for images. And then with this very unassuming paper from Google called Attention is All You Need that introduced the transformer. And when you look at ChatGPT, the T stands for transformer. So it's a generative, pre-trained transformer. Generative means that it's about generative AI, and I'll talk more about that. Pre-trained means that you can grab a giant corpus of all of human knowledge, if you wish, and then every task that you ask it to do is an emergent behavior. So you're not training machine learning for a specific task, but you're training to be general. And then transformer is this ability to now learn from context. It's the concept of attention, the fact that every word links through many different links to every other word, and then suddenly concepts emerge. And that transformation is a technological marvel. It's an engineering prowess, but what made the difference is that it's in the hands of everyone. And we in the AI world have been using such models, foundation models and representation learning and all of that stuff for a long time.
Right.
But the difference with ChatGPT is that it was smack in your face. Look at what this can do.
So do you feel like you were not that surprised by when ChatGPT came along because, like, to you, this is a little bit of old news?
The technologies were definitely leaning that direction.
Okay.
But anyone who says they were not surprised are just lying.
Right.
I think we were all surprised, and I continue to be surprised.
Right.
I understand the underlying technology more than most people, and that basically means that I will not either get overly excited about what it does, but at the same time I will not say, oh look, I can trick it to do stupid things, because frankly, of course I can trick it, just like I can trick my children to do stupid things. So basically, if you understand that it's a language model, if you understand that it has access to a vast corpus of data, if you understand that it can abstract away from massive numbers of documents that you feed it, and if you understand that by guiding it in the right way with the correct set of prompts, you can basically make it do extraordinary things, then you appreciate it as what it is, a tool, not some superhuman being, some intelligent thing. No, it's just the next level of progress that started out with writing,
Right.
that continued with the printed press, that continued with the internet and the World Wide Web, that continued with Wikipedia, that continued with social networks and the spread of information from everywhere to everywhere at once, that continued with preprints and the fact that whatever I publish today can be read by thousands of people across the world immediately. And that instantaneousness has now been taken not just to the level of information access, but to the level of information integration. And I would say that ChatGPT is the great integrator. It's not just a language model. It's, you think of it like a rapid lookup of knowledge, but it's a rapid integration of a ton of documents. And if you understand it in that perspective, then it demystifies it, but it also makes it much more useful.
It's interesting too that you talk about it as a tool, which I think is such a good comparison, because every tool can be used for good and for, like, are books inherently good? Is the internet inherent? Well, obviously, like, there are different things on the internet. There are different books, right? And then so this is neither inherently amazing nor inherently terrible. It's just a tool in that progression of tools.
And you can use a hammer the wrong way. You can like bang your fingers,
of course.
or you can like really nail it.
Build a house,
literally.
Right.
And the difference is that many people are saying, look, I can trick it to do this. We have to put guardrails. And I'm like, that's ridiculous. No. The moment you shift the responsibility from the tool to the user, I'm not going to sue the hammer company if I kill somebody with a hammer, or if I run somebody over with a garbage truck. That's not what it was meant for. And I can't put enough guardrails around everything in society that it can't be harmful. And in the same way, we should say the user is responsible. If you use it to create spam, if you use it to create malicious stuff, if you use it to create bombs, etc., you are the responsible person. Or there's information out there in other ways that you can integrate. Just because it's the next level of more powerful technology doesn't take the responsibility away from the ultimate user of the system.
I know you talk a lot to people in business, to people who run businesses. And I wonder what your sense, obviously businesses have tried for 2 years to get their arms around this technology, to have people learn more about it. And I wonder what your sense of where business, just at a high level, then we'll dig down a little deeper, but like where people are with that. Is it mostly that people are kind of like stuck in the pilot project phase because they're afraid to like do the full thing because who knows? Just give me a sense of what you're seeing.
The trouble is that ChatGPT is already so extraordinarily powerful that many companies are faced with this dilemma. Do we train it from scratch? Do we incorporate our own data? Is it ready just off of the box to just do everything we want it to do? And I think that's the dilemma. On one hand, you can basically have a system that's ready to deploy and that can do some very, very impressive things, but with no knowledge of your corporation. Mm-hmm. On the other hand, you have this extraordinary ability with the foundational tools of large language models and with open source models like Llama 3 and you name it, to basically deploy just massive compute, train with your own data, and then have a system that truly understands your corporation. I would say that one of the things that we're missing between those two alternatives is a system that can not only answer that one question, but can show you the landscape of data and information in your own corpus, or in your own corporation, or in your own domain of knowledge that you're interested in. Let me give you an analogy.
Okay.
Right now, ChatGPT sits behind a giant glass window, and there's a little slot through which you can slide questions.
Okay.
And it then goes everywhere. Imagine Aladdin and a genie
Right.
flying around massive, massive amounts of information, and then gathering stuff for just you, and then it gives you back a piece of paper through that hole. Mm-hmm. No one has opened that gate to let humans in. And I think that's what corporations are missing right now. They don't want just one answer at a time, because this is a very archaic way of communication. It's the traditional speech, which of course has been around for 70,000 years, but it's very slow, and it's one answer at a time, and it's one bullet point at a time. And yes, maybe that's how most people consume information, but maybe the CEO of that corporation wants to actually see the entire landscape of data. And maybe that's not true of just the CEO. Maybe every person will actually change their mindset if you asked a question and it gave you 20 bullet points, and it highlighted in a map of all of the documents in your corporation the 10 documents from which it pulled those highlights. And then you have the option to basically go into that part of the landscape and look at these documents in more detail and understand the provenance of the information, but also look sideways and say, hey, what else was there? And what am I missing? And also say, oh, well, I'm not touching at all that entire cluster of documents here. Why are you not telling me about
Right,
that?
right.
So humans have evolved with an extraordinary sense of space, of topology, like landscapes. You can sort of walk through a forest and somehow find your way out,
Right.
because we have this spatial reasoning. And when we look at a map, a physical map of a ski resort, for example, we can immediately understand so much more than if we had a chat interface and we ask, hey, where should I turn next? And it would say, oh yeah, well, after 3 things, go turn left, and after 5, go turn right. We're not using our visual system, our spatial reasoning, our hierarchical levels of abstraction that humans have unique capabilities for when we're using that chat interface. So I think what's missing is not just the ability to integrate all of your data into a chat system, which I think many people are moving towards, but it's also the ability to have a control panel, a control center, where you can basically not just look at one document at a time, but actually understand the progression of data over time, quantitative information of over hundreds of thousands of documents that lets you understand the main clusters of ideas and how they relate to each other, that allows you to put links
Right.
between all of these different places in your landscape to each other. And I think that component is something that will transform the way that we think of data. And I would even argue that part of the reason why humans are so afraid of AI is because we have created this landscape of data that it doesn't let us in on. So we feel like outsiders, and we're like, oh, well, AI is going to clearly replace our job, because look at how it travels like a genie inside this amazing castle of data that we've built, and we've locked ourselves out. If instead we used AI to take us on the magic journey with a magic carpet and fly through the data and look at the data firsthand, along, of course, with the synthesis, but with all of the attribution, all of the transparency. Like, if we peek inside the AI brain and we see how it works, I think people will trust it more. People will feel more confident to also intervene. People will be able to be part of the equation and get much, much better results.
So, and this leads to a couple questions, but one is, it feels like you're saying, yes, people are impressed by AI. Yes, people want to integrate it, but the kind of killer app you're describing hasn't come along yet, or it has not been implemented yet. Has it not come along?
It hasn't come live yet.
Okay.
It hasn't come live yet. So part of the reason why I can imagine it in such great detail is because we have built it.
Okay. So we're talking about the killer app right here.
So we have basically built a system that allows you to visually see hundreds of thousands of results. Ask the AI about them. Use a lasso tool to select documents that you care about.
Give me an
Use
example
filter.
of something that somebody might like. What might somebody want to know, and how would this be useful in like a really concrete way?
So I run a complex lab.
Okay.
We have maybe 12 different teams, and they're
Okay.
all working on different aspects. I have created ChatGPT sessions for every one of those teams. So every new meeting minute transcript goes into the same ChatGPT session. And therefore, it has an institutional knowledge that it's building for each of those. So that basically means that every time I wrap up a conversation, I create that document there. A different team in my own group has its own thread.
Okay.
And right now they're sitting as silos, separated from each other.
Right.
If I want to find an insight that I had in this thread that would be relevant to another thread, they're siloed. It's impossible to cut across.
Right.
If I put all of it together, it's going to be completely confused, because suddenly it'll have ideas, from, I don't know, obesity applying to Alzheimer's and so on and so forth.
Okay.
So what we need is this ability to now take all of those ideas into idea space and trace the progress of one group and create these microlinks to another group. And that's what we're doing. This is one of the killer apps to basically what I call it, do not leave serendipity to chance. So we want to sort of have this wine cooler conversation, or sorry, water cooler conversation. Wine cooler is even better.
Different kind of conversation. It's fine.
This water cooler conversation where you can basically like say, oh, by the way, what are you working on? I'm working on so and so. Oh, that's a great thing. And I had a similar conversation yesterday. So that's what the PI does. The PI, because he's working with everyone, he can be like the principal investigator. He can be like, oh yeah, talk to this person, talk to that person, make these connections. What we need is systems that are able to both track and support, but also, of course, amplify, but also provide that perspective. So basically what we have now is, we've ported these thousands of documents, thousands of minutes, thousands of papers, etc., into that system, so we can kind of create those links. We can create connections that would otherwise not be possible.
And you think that is at some point coming for companies, so that the marketing in one part of a financial company and a marketing in another part understands that they're just reinventing the wheel because these people already did this thing and they might as well learn from that and whatever, and they should have a meeting.
You and I were just talking about that
earlier.
We
were.
Basically, you were saying, hey,
Silos
there's all these people
common.
who are, doing the same thing. And even within MIT,
Yeah.
to create such a system. And I've had such great feedback from so many people in the administration who are like, wow, we need this now. And when I showed this at Harvard Business School, they said, oh, we want this yesterday. And we want to connect with our alumni. And I work with people working on patents. And they're like, oh, I want to use this now. Because every time I want to see prior art, I want to understand the whole landscape of prior art.
Right.
I've spoken with people in the legal profession who are basically saying, I want to find every legal case and sort of create the landscape of all of that, and then understand what is the knowledge, what are the patterns, what are the principles, what are the prior decisions that I need to extract for every one of those cases. And I want to actually look at the data. In the medical profession, we're working with a company that's now dealing with 5 million medical records, and they want to be able to know, why was a decision made? How is the patient progressing? What are other patients from whom we can learn? Mm-hmm. And how can we connect that across these different people? Mm-hmm. And in every single one of those cases, attribution, transparency, accountability, traceability, they're all key. Mm-hmm. And right now you don't have anything like that with the current systems.
So let's zoom out. It sounds like you think that, yes, AI has a huge amount to offer businesses, but that a lot of that promise has not yet come to pass.
We are just at the first baby steps.
Okay.
And the step 0 is just start using ChatGPT, for God's sake. Just get everybody a Prime, paid account, and just, unleash their potential. Number 1. Number 2 is start integrating some of your own data. Microsoft has some offerings, and others. You can basically now get a deal for your corporation where some of your data is integrated into their system. Level 3 is create your own language models with the data from your corporation. Level 4 is create multimodal representations of your data. Mm-hmm. Don't just think about text alone. Think about every diagram. Think about the images. Think about videos. Think about transcripts of videos. Think about meetings and recordings of attendance and structured data, and how you can link all of that together in multimodal representations, which basically means that when ChatGPT is able to sort of, for example, generate an image, how does it do it? Because they've trained it in a multimodal fashion. That basically means that when it sees an image, the parts of the image that are being recognized, from the pixels to the lines, to the shapes, to the objects, are represented in both language and image at the same time. So you can actually ask questions about those elements. And in that multimodal step, we ourselves have built these foundation models that speak protein structure and language at the same time. Why? Because we can then reason with the English speaking component of the model about parts that humans do not have words for. Mm-hmm. And it can reason about structures. It can reason about chemical entities, about patient states, about cellular transcriptional states, about molecular properties, about DNA code, the language of DNA that frankly humans never evolved to speak. Mm-hmm. Human language is constrained by the capabilities of humans. It is extremely matched to our cognitive
Right.
functions because that's how it evolved. Otherwise, if something is not easily parsed by many, many humans, it will not make it into the language. Mathematics is a whole other world. Physics, chemistry, biology, all of these things are not constrained by human language. So the ability to build these multimodal models that connect data, raw data, from your corporation to text and memos and descriptions and conversations will then unleash the capabilities of these models to now start reasoning at a way, way deeper level. And that's level 4. And then level 5 after that is go beyond just one answer at a time and start thinking about the landscape of answers in these multimodal embeddings, to start becoming super users, to start asking more of our AI. When I asked Google to take me somewhere with Google Maps or Apple Maps, then what I get is not just turn left, turn right, turn left, turn right. That's the stage that we're at with ChatGPT now.
Right.
As opposed to, hey, here's a whole map.
Right.
Here's how you navigate
Right.
from point A to point
Well,
B.
and you even see a little bit, here's what people have been ordering at that restaurant. Like they've already started to add on, like, this isn't just an answer to your question. Here are some questions you haven't asked, but you might want to ask.
That's exactly right. And that's the integration, that's the multimodality, that's the sort of bringing in many different sources of data all together at your fingertips.
So everything you've talked about has been built on data. Mike Stonebreaker here has talked a lot about how poor data is in many, many companies. Allowing for the possibility that, yeah, in some companies it's pretty good. I wonder if you worry that in many companies it's not. Like, you can't get something out or if you don't put something decent in, right? And I just wonder if that's a concern and a limitation. Like, AI cannot work if you just don't have much to offer, or things are completely not cleaned up, or they're all a mess.
In computer science, we always say garbage in, garbage out. In other words, if your data is crap, then the answer is going to be crap. I would argue that AI might allow us to go a step beyond that. And the reason is, for example, multimodal learning. If I learn in multiple modalities at the same time, I can then recognize when one modality doesn't quite agree, and I can flag potential errors in the data. So, for example, we built this multimodal patient electronic health record system for medical data a few years ago, and we were able to look at the doctor notes, the prescriptions, the lab tests, the billing codes, the DRG codes, and all of that at the same time. And that revealed just how crappy any one of them was in isolation.
Right.
But by putting it all together, you're suddenly building on top of each other. Now, there's been a lot of talk about the fact that I can show you a picture of a giraffe and I can change just a few pixels that are imperceptible to the human eye, and suddenly you see an airplane.
Right.
Or at least the AI sees an airplane.
Right.
And that is much more robust when you use multimodal models. In other words, the ability to constrain your model with another data stream can go a long way. And now, as companies are thinking, okay, what do we do with the data? How do we clean it up? I think one component is absolutely multimodality. Another component is fail fast. In other words, do checks early on as you're ingesting the data to basically make sure that things make sense.
Okay.
Ask questions about, hey, what do you think of this data, etc. So basically, when I use ChatGPT, I always say, how do you understand this document? Actually, I disagree with your interpretation of number 4. Can you skip section 5? Can you revise section 3? Can you combine 1 and 7? And so on and so forth. And that ability to sort of build progressive understandings of context and data streams and modalities, etc., is extremely important. And of course, the last step is bringing in the visual component. If you create now a landscape of all your data, then you can basically see that, hey, this thing's sticking way out. And this landscape can be built based on the latent embedding representations of your documents, and of every sentence, and of every section, and of every paragraph, and of every image, and every diagram, and so on and so forth. And this ability to visually see outliers is something that humans are extraordinarily good at. And if only we allowed our AI to be so transparent that we can see where its thoughts are projecting. So imagine if in a classroom you could see the firing of every neuron of every student, and you could see patterns in that firing, and you can see some homogeneity when people are sort of getting it, and you can see that some person is thinking about something different. You can be like, oh, well, let me explain that more, or hey, Timmy, can you please explain, how you're thinking about this, etc. And I think, of course, this is science fiction, very, very weird and scary. But we can do that in a less scary way with the AI.
Yeah.
We can be basically like, okay, I have all these AI agents. Let me now look at their neurons and see how they're firing. And I can see patterns of firing that are just not matching with the data I'm showing it. And this is not science fiction for the AI. We're currently doing this in my group. We can basically see what is the latent representation that you have of all of these documents. And if I now take medical records and I visualize the latent representation of these medical records, do I find discrepancies where that patient maps here based on the doctor notes, but maps there based on their data? And I can flag a discrepancy. We can identify sample swaps in our data. We can say, well, this patient clearly doesn't look like the labels that that patient was given. So we can use all of that information to now not only build more powerful systems, but go back to the data and flag discrepancies or flag inefficacies or flag, misinterpretations, and then do that early on by stress testing the system as you're building it.
So let's dive into one area of business. I know that people coming out of your lab, some folks go into pharma. And I wonder, it's a really interesting area when you think about how AI is going to be used. How do you think it will change the development of pharmaceuticals in this country or around the world?
I think that AI has changed so much of the landscape of knowledge already. In so many different areas, AI has had a profound impact and is about to have a way more profound impact.
Okay.
But perhaps the area where AI will be remembered as having truly changed the human condition is probably medicine. And the reason is that it is so darn complex. In other words, as I mentioned earlier, the human language is fairly simple by comparison. We only have had 70,000 years to develop language. Every child is presented a very different subset of the corpus of all of human data, every human book, and yet they pick up language extremely fast. So it's a relatively simple, from a computational complexity perspective, form of communication. DNA has been evolving for 3.5 billion years. Proteins have been folding for 3.5 billion years. Chemistry has been changing and, being reshaped initially by physics for the first 10 billion years or so, but then by biology in ways that are way more complex than physics alone could achieve for the last 3.5 billion years. So we now are taking a world of structure, a world of DNA code,
Right.
a world of chemical interactions and protein interactions and protein folding. And every single one of them in isolation is harder than any human language that has or will ever exist in isolation. But now you're putting all of that into the body of a human, and you have interconnected immune system and neuronal system and vasculature and muscle and hormones and electric signals interacting with each other and creating their own language of communication. So there are interfaces that cells use to talk to each other. There are interfaces that proteins use to interact with each other. This is by far the most complex aspect of the universe. All of physics could be described with, maybe 50 or 100 equations, if we understand it all. Biology, as many as there are genes. In other words, there's a small number of principles that are emerging, but the rules of biology are rules of adaptation. They're rules of tinkering. They're rules of evolutionary niches getting filled. So that basically means that inherently biology is the most complex thing in the universe. And we now have reached the limits of what science can do for understanding the human condition, for understanding aging, for understanding Alzheimer's and cancer and cardiovascular disease and immune disorders and so on and so forth. But my hope and my wish, and frankly, my day job, is can we leverage now all of these extraordinary capabilities for new AI systems, for new representations, for new multimodal representation learning, for extracting knowledge into knowledge graphs, into patterns of interaction, into all of these different components.
Things people couldn't have seen before, or like figured it out sort of with the, getting the pencil out.
A lot of people are worried that AI will just replace traditional jobs where humans could do it. And yeah, that's true. But, humans will find new jobs that are much more complex, hopefully. With biology, there's no hope of humans doing it alone. So this is the final frontier. It's both the most exhilarating, the hardest, and the most impactful thing that we can do.
Is your sense that much better drugs will come out of this than, let's say, have come out of a more traditional process over the last, 30 or 40 years that has been used?
So the traditional process of drug development is one gene at a time. You study one protein, you figure out how the structure of that protein works, you figure out what it does, you design a compound, you go after that one protein, etc. And that costs about $1 billion per drug, at least. The serendipity approach has been much more successful of try a bunch of molecules and see what they do.
Right.
And then, sort of there's a few miracle drugs that are just pure serendipity. But all of the rational drug development has been constrained by how we teach engineering in school, which is you isolate the system, you take apart the parts, and you go into one component, you edit that one component, you hope for the best. Biology doesn't work that way.
Right.
Biology is messy. Like there's things happening all over the place. Part of the reason why we're having so much trouble is because Alzheimer's is not down to one protein. That's ridiculous. Alzheimer's is extremely multifactorial, and so is cardiovascular disease, etc.
Right.
There's a small number of rare disorders which are genetically driven that have a single, alteration. You can fix that alteration, but the vast majority of complex traits are extraordinarily multifactorial.
Yeah.
So what we're doing now in my group is understanding the basic foundational building blocks of these disorders, because yes, there's hundreds of genes involved, but they are converging in a small number of hallmarks, in a small number of buckets, of principles, of pathways, of biological processes. And by understanding the modular view of biology and medicine and disease, instead of just thinking of Alzheimer's as a monolithic disorder,
Right.
let's think about the vascular component. Let's think about the lipid transport, cholesterol metabolism, neuroinflammation, microglial, states, and so on and so forth. And you can isolate each of these components and start building therapeutics for these parts. And there's maybe going to be 20 modules, if you wish, that are underlying Alzheimer's. This is economically much more feasible. Why? Because if we want to design a therapy for one person, no one can afford $1 billion drug.
Right.
I mean, there's a handful of people.
Right.
But if instead you say, I'm going to build a therapy for lipid dysregulation or cholesterol transport, then that module can be reused in millions of people. And moreover, I might build it initially for that component of Alzheimer's, but it might be reused in cardiovascular disease and reused in metabolic disorder, and you name it. So that modular approach allows you to now think about what are the core building blocks, how are they reused across disorders, and most importantly, how are they combined in every new person? And that's the secret to personalized medicine. We're not going to personalize medicine by creating a pill for you. We're going to personalize it by understanding what is the number of dysregulated modules.
So you've got sort of Legos, and you're building your unique Lego thing, but
That's exactly right.
the Legos are mass produced.
That's exactly right.
I mean, it sounds like a lot of this is work that you're doing, but I do wonder, do you think, like pharma companies, biotech, it's a vast landscape out there. Are they changing quickly? I mean, they've been doing things for a long time. People are in companies, like people might have 30, 40 years in a company, like people have long careers. They don't necessarily, and this is true of this is not just pharma, this is true of any industry. Are these big changes that you see like taking the world by storm? Are they creeping in more slowly than you'd like to see?
There's a small number of pioneering efforts that are completely embracing AI, that are basically taking this multimodal representation learning, this geometric deep learning for understanding how proteins function, for solving the structure to function problem, for understanding how chemicals can be represented in their latent, spaces, and how to map now building blocks of proteins and building blocks of chemicals and how to put them together. And there's a small number of billion-dollar investments into startups that are basically saying, okay, great, let's revolutionize the way that we do generative learning for protein design. Or that we do...
Which is scary, because you're like, well, let's do something completely different. This old way... It's always hard to start something new, because you don't exactly know what the end result will be.
I agree completely, but it's not completely new.
Yeah.
It's something that we have seen the extraordinary power of. There was an AlphaFold moment where suddenly we could solve with these deep learning techniques protein structures almost as well as the experimental methods. That was a tremendous moment in biology where we could basically say, whoa, there's something fundamentally different here. And these new billion-dollar investments are building on that transformation. They're basically saying, yeah, let's use now this ability to, go to the next level.
This is, a little bit connected, but Neil Thompson, who's also here at CSAIL, has talked about his concern, I wonder if you share this, that the cost, and you can see it also by how much money Elon Musk and Sam Altman are all raising to build data center. I mean, these are huge, huge investments to increase the amount of compute. And actually, Sam Altman said recently when he first created OpenAI, he had no idea how much money he would end up asking for. He didn't think it was like a big investment sort of thing, but it has turned out to be. And so one of the things that Neil Thompson has said is that because of that, because the compute power has just grown astronomically, a lot of the really cutting edge research, it's hard to contain it within a university now because universities don't have the kind of money that Microsoft does or that Tesla does or whatever. They can't go out, and so I wonder if you worry that much of the cutting edge research is being taken over by industry, especially in this is a domain that has become very expensive.
I agree completely that to build a foundational model from scratch and to train it based on the entire human corpus has cost an enormous amount in the last few years. That said, this is not the only direction of innovation. This is the direction of innovation that you go after when you have massive, massive investments. And that makes sense. But it doesn't make sense for everyone to build their own such model, number one. Number two, we can build on those models. We can basically now create layers that are using these, extraordinarily powerful language models as a building block.
Okay.
And that are using these protein folding models as a building block and now combine them in new intelligent ways. The extraordinary competitive advantage of academia is the influx of young talent. Being able to identify such talent across the world and bring them together to work on the frontiers of these problems is something that academia does better than any other institution in the world. And perhaps we could leverage the two together. Perhaps the right solution going forward is, can we build on these extraordinary resources that Google and OpenAI and Microsoft and Amazon and others have, and build on the extraordinary creativity of academia across all levels, from the undergrad to the graduate student to the postdoc to the professor, but even at the level of the high school students. I'm currently working with 40 extraordinarily creative high school students who are truly pushing me in directions that I didn't think I would go before. And I think blending these boundaries between academia and industry and government, I think is very, very powerful. Having government level resources that are put out for academia, like some of the national labs, some of the country level compute capabilities can be leveraged where not every university needs to build their own. That's ridiculous. Right. But if instead you had some national center for AI computing or something that you could sort of apply for grants for, or sort of collaborate in, etc., and then not like every grad
DARPA
student
2.0 or
that's
something.
Exactly right. That's exactly right. And the other trend, of course, is that training these models is becoming much cheaper. That we're learning that perhaps we don't need 7 billion parameters. That basically this absolutely has been the scaling law. Number 3, that scaling has kind of tapered off. We don't see the rush for bigger and bigger models because frankly, maybe we've extracted every ounce of knowledge that we could, and insight that we could out of the data that we have already. And maybe we've saturated what we can extract from human knowledge. So maybe the model will basically not get any better using the traditional approaches. And maybe the next level is new architectures, understanding better specialization of these neurons, understanding new neural connectivity architectures. So the human brain has, of course, the neocortical system that's organized in these layers of abstraction, very similar to basically what inspired the modern revolution of deep learning representations. But it also has a lot of subcortical systems that are wired in very specific ways. And a lot of learning is distributed across these different centers. So basically the motor learning center in our cerebellum is also, of course, speaking with the M1 primary motor cortex in the neocortical region. And the patterns of learning, of course, connected with the hippocampus, connected with a lot of the emotional centers, with a lot of the reward centers, etc., the stress factors, all of these are contributing to the modes of learning that you have. We haven't begun to explore this extraordinary diversity of architectures that nature has already come up with in our own apparatus, number 1. Number 2, we're not constrained by evolution when it comes to designing these systems. They don't need to start as a single cell that then divides at every generation and rewires the whole thing and runs on 3 watts instead of 300,000. So I think this ability to learn from nature, but also to somehow not be constrained by nature and developmental or evolutionary constraints, could unleash a whole new level of architectures that are much more efficient at learning and that are leveraging these capabilities of what we've learned so far by large language models, that are improving on these architectures, making them more compact, changing the paradigms, and so on and so forth. And I'm very, very hopeful that it will not always be the case. There will always be need for more hardware, and that's where collaboration comes in. Right. That's where national investment comes in. That's where industry, academia, partnerships come in. But there's also room for innovation that is not just about building the next biggest foundation model. Okay. But is about sort of pushing the state of the art in other ways.
I'll throw in Sam Altman one more time, because also in this interview he gave December 2024, he talked about working on artificial general intelligence, which I think is like, for him, this thing that looms really large. He's very excited about. Talk about that. I know you get asked a lot about this.
The trouble with AGI, with artificial general intelligence, is that every single time we see a machine do something, we say, machines can do that. That's not intelligence. Intelligence must be that other thing that humans do. And it's been like that for decades, not just years. So before it was, machines can't do integrals. That must be intelligence. And then machines could do integrals better than humans. Right. That's not intelligence anymore. Right. Machines can't do, basically, for example, intelligence used to be, can you multiply like 2 giant numbers in your head? Yeah, some very intelligent people can do that. Right. But maybe that doesn't translate to general intelligence for these people. Right. And then machines got way better at that than humans, so that's not intelligence. Chess, machines will never beat humans at chess. And then guess what? They do, and they just destroy us. Right. That's not intelligence anymore. Right. That's what the machines do. So intelligence must be something else. Right. Intelligence must be looking at images And now machines can look at images, and they can do that, probably better than humans.
Right.
And what's really funny is that we're now hitting the level where some of these capabilities are not uniquely human. So dogs can recognize images, and chimps can recognize images. So we suddenly started saying that intelligence is the things that machines do that humans do very naturally. And those things, guess what? They're also done very naturally by animals. So maybe that's not intelligence either. And then you get to language, and you're like, aha, language is the one thing that machines will never do. And now, I'm sorry, machines are doing language probably better than the vast majority of humans. So we're like, that's not intelligence. Something else must be. And now intelligence is about reasoning and logic. And guess what? We have specialized systems that do reasoning and logic better than we do. We're like, well, that's not intelligence, because we kind of understand
So
how
you're
we
saying
build
with
those systems.
AGI, like the bar keeps moving, so we never really get to it because AGI isn't like you. I recognize you are a person, and like it's not you.
Yeah,
So then
yeah.
it's not AGI.
Exactly.
it
So
can't
so
get
basically,
there.
the Turing test was a very well-defined thing
Yeah.
that basically said, if behind a wall,
Right.
I can sort of spend 10 minutes interviewing someone and can't tell if they're
Right.
human or machine,
Right.
then that's AGI. And I'm sorry, we've long passed that.
Yeah.
so
Yeah.
so basically now, some people are saying, oh, but humans have emotions and they grunt and they feel and they touch. I'm like, yeah, but so do chimps. Like,
Right.
you have on one side the bar of animals, and on the other side you have the bar of extraordinarily impressive single task systems.
Right.
And now you're getting to the multitask systems. And the reason why so many people are talking about AGI right now is because ChatGPT is just freaking so good at so many things. And I think that's why they're basically saying maybe we should be fearing AGI. And guess what? Humans can also just like stand up, walk around, open a door,
Right,
etc.
right.
And of course, humanoid robots are coming for that as well.
They are.
And we now have these extraordinary new actuation devices, new batteries, electric motors instead of the hydraulic motors. These machines are getting way better and better and better. So basically, is AGI about embodied intelligence? Yeah, of course, there's some component of embodied intelligence. And me having experienced the natural world gives me paradigms for thinking about complex, abstract objects
Right.
that AI doesn't have access to, because
Right.
it hasn't
Right.
played
Right.
with dirt
Right.
and jumped off a tree
Right.
and so on and so forth that all of us have.
Also, I mean, I think the problem with AGI as a concept of people being replaced is that only goes as far as people want people to be replaced. Like if I want an attorney and I hire you and I don't want a robot, even if it can be just as good and even maybe much smarter than you because it knows every case, and I'm like, no, but I want a person. I want a person to say, there's also a barrier to how much people let automation or robotics or whatever be subbed for other people.
I agree. There's one component of that where when I go to the doctor's office, I don't want to say, hi, my name is Dr. So-and-so. And so,
Right.
that's
Even
ridiculous.
if they're
the human
more
aspect.
knowledgeable than your doctor.
Yeah. But the place where this becomes interesting is when you don't have to choose one or the other. You get to have both. In other words, do you want a lawyer human? Do you want a lawyer machine? Or do you want a human lawyer that also has access to the best lawyer machine? I'm like, I want third. Do I want just a doctor, like human doctor, or AI doctor, or a human doctor that has fast access to AI capabilities?
Right. And
I'll
good
take the
bedside
third.
manner.
Yeah,
Right.
that's
right.
exactly
Both,
right. Yeah. And this is almost starting to become the great equalizer, in the sense that AI can allow the most empathetic teachers to teach students with the most inspiration and kindness and comfort, while having AI do the most complex cognitive tasks. In other words, we don't have to choose, do I want a smart teacher or do I want a kind teacher? I can have both. And I can err on the side of kindness because that teacher will be augmented with AI. And maybe the great equalizer will be that everyone will have a superhuman capable assistant for anything we do.
Right.
And that also enables the human component, where ultimately there's some accountability, there's some responsibility, there's some basic, common sense that no, I'm not going to kill 100,000 people because I misunderstood the question. Like there's that ability to sort of stop and say, no, that doesn't actually make sense. So you can't trick humans as easily as you trick machines. And part of the reason is the multimodality. It's the fact that we understand from so many different sources of data, so many different paradigms, embodied and physical and, you know, cognitive and emotional and relationship wise, etc. So I do think that AI is getting to superhuman capabilities for dozens of tasks. And I think that by almost any definition of AGI that we had through the years, we've surpassed them all. So one could say AGI is here already.
Right.
Or one would say that the human replacement is the level at which AGI is really defined. And that would involve reasoning and common sense and emotion and movement and sort of empathy and all of these things. And A, of course, I'm not sure we want that.
Right.
But B, it starts at some point questioning what makes us human.
Yeah.
And I often ask myself this question: am I a good advisor? Am I a good dad? Am I a good teacher? And what I've decided to answer it with is, am I doing what a good teacher would do or what a good parent would do, etc. And if I love my kids to pieces, but I'm a terrible dad, it doesn't matter that I love them to pieces.
Right.
So at some point, it also begs the question of, are humans faking emotional warmth? Are we faking deep reasoning? Are we just, glorified LLMs? And
Hopefully not.
well, that's in the eye of the beholder. And when we are asked, why did you think that? We are sometimes able to answer, I thought that this way. Sometimes we can't, but sometimes we answer. When we answer, did we really think of it because of that? Or are we making up a story to explain our behavior to try not to be caught off guard? And there are experiments where, not experiments, but there are experiences where because of an accident, a human, for example, had a severed corpus callosum that connects the two hemispheres together. And with one eye, they could do some things, and with the other eye, they could do some other things. And you could tell one eye something by, writing it, and you could sort of, it wouldn't go to the other hemisphere.
Okay.
And they were asked, go in the fridge and pick up a beer. And they go to the fridge, pick up a beer, come back. And then they would cover the other eye and say, why did you pick up the beer? Oh, I was thirsty. It's no, you just made up a story to explain why you did this.
Right.
And this happens to all of us. We basically walk to the other room and, pick up the wrong object and come back and we're like, oh, no, it turns out I needed this. And one way to think about our brain is this awesome employee who's super diligent and never wants to be caught off guard and will make up a story to explain what just happened.
Yeah.
And I think that, maybe the AI, obviously the AI is doing this because it doesn't have a reasoning center, or maybe it does. And maybe that reasoning center sits in a set of neurons inside the giant 5 billion parameter LLM. And maybe that reasoning center sits somewhere in our trillions of neurons with, its own, reasoning LLM. And I think that this blurring of the boundary between what is a human unique capability and what is an AI also capability is sort of one of the things that will continue to challenge us, because on one hand we had animals, on the other hand we had AI,
Right.
And now we're starting to wonder, well, aren't some of these clearly human behaviors of empathy and you name it, maybe learned? Are we maybe faking them rather than feeling them? What explains the warmth and the attachment that I have to my children? Of course, there's an evolutionary pressure there. If I didn't have it, nobody would put up with kids. And then the human species would go extinct.
Right.
So basically, I think that, sort of this, let me just say, I am thrilled to be living in this world where we live in, where we can ask all these fundamental philosophical questions that have bugged humans for thousands of years. I mean, in ancient Greece, we would be having the same debate really deeply, perhaps not on camera, but
Probably not, unless I'm missing some knowledge about ancient Greece.
but we now have these extraordinarily seemingly intelligent machines
Yeah.
that we can reason about, and that can reason with us about how they're themselves reasoning. And we can keep questioning, wait, if the machine appears to have so much insight in how it thinks, even though it clearly doesn't have consciousness because I didn't code it in, is it that I uniquely have consciousness? Or is that I'm faking it just like the machine is? Or does it actually have consciousness and it's just an emergent capability from these billions of parameters? And that we might never know.
Right.
Or by being able to poke and unplug wires inside the brains of these machines, as I was saying earlier, by being able to observe this latent space of reasoning models and trying to see sort of where does self-consciousness, in that machine sit. Can I unplug it? What was the group of neurons that was exhibiting it? Maybe we might actually understand something about the human brain as well.
I have two quick final questions for you. One is, we were talking so much about how medicine will change and your kind of hopes about how it will change. I think, to an ordinary person, they think, look, there's a crisis in primary care physicians. I can't even, I call up, I'm like, I'd like a doctor's appointment. They're like, we'll fit you in 15 months. You know what I mean? And I think there's a little bit of a mismatch between all this amazing stuff that's being worked on sort of in a lab, whether it be in academia or in business, and people's actual experience of I have to fight the insurance company. Could you really make medicine better? It feels like a system that's so broken.
It's a fantastic question. And I want to say a couple of things first. Let's start with how spread thin we are. Everybody says, oh, you got to stop machines, are coming for our jobs. And everybody's like, I don't have time for my family. I don't have time for my kids. I don't have time for my elderly parents. I don't have time for leisure. I don't have time to eat. And how do you reconcile those two? Don't take my
they
job.
Also need money to eat.
But basically what I'm trying to say is that we have made extraordinary exponential progress for thousands of years. It is the same exponential we keep riding. It's not a new exponential. It's just steeper where you are because it's an exponential. It gets steeper as you go. So we are, at the tail end of this super, super steep exponential. That has led to tremendous progress. And progress is undeniable. We all have better health, better food, better shelter, better education than at any time in the human condition in the thousands of years that preceded. At the same time, there's more inequality. At the same time, there's more stress. At the same time, people are, eating way more junk, etc. So this exponential acceleration has led to some things that are not quite optimal there yet, and many, many things that, all of us say, oh, yeah, 50 years ago, this was way, way better. For, I don't know, family units and, multi-generational households and leisure time and food quality and, work-life balance, etc. All of these things were arguably better, a few decades ago. Now, the question is the world getting objectively worse? Is it getting objectively better? Or are there components that are getting better as other components are getting worse? And in my view, in this crazy sinusoid that is not just going only up, but is going up and down, where some things are getting way better and some things are getting way worse, and it's like the distribution is getting way wider about the level of awesomeness of different components of our lives. Maybe AI could be the solution, not the trouble. Maybe having AI assistants would allow 20 times more teachers to be able to teach than the number we have now. Maybe it will give us more time to take care of the elderly. Maybe it will give us time to spend more time with our kids. Maybe we'll give our kids the ability to learn while having more time to do other stuff, and so on and so forth. So I think that this stretched thin aspect of society could perhaps be dramatically improved with AI. And now, of course, the question of income inequality comes in. The question of, do I have a job, comes in.
Right.
The question of, can I feed my family, comes in. And that's a place where we have been terrible in the past, perhaps because of limited resources. But maybe in a world of dramatically increased productivity, abundance, health, cognition, education, etc., maybe in such a world, there will be actually the opportunity to just provide a basic income for everyone, to provide healthcare as a basic human right to everyone, to provide extraordinarily quality education as a basic human right for everyone. And maybe that will lift up all of society, and maybe that will actually lead to that human condition improvement where you don't have to complain about all these terrible things that are happening at the same time as some things are objectively getting better.
There'd be a fascinating file of AI. Last question. We're at the beginning of a new year. Give me your sense of like, what is your prediction? Maybe for 2025, you could go even beyond that, but is there something that you think is sort of on the horizon that's really going to impress people, surprise people, you know?
I will start with two quotes.
Okay.
The first quote is, it's very difficult to make predictions, especially about the future.
Yeah, it's a good one.
The second quote is, the best way to predict the future is to invent the future.
Okay.
And given those two, I will tell you that what's coming is, at least from my own work, this ability to combine the visual and the language and the multimodality and the transparency in a completely new way to interact with AI. And I think that will dramatically change the way we see data. I think that data science right now is at its infancy. And that when my kids do, I don't know, they sort little cards at the age of 3, they're sorting the square and the triangle and the blue and the yellow and, you know, etc. And they have cards on the carpet that they're shuffling around. And I think that's a very natural human behavior of just organizing stuff. And, you know, my extraordinary admin, her dad says that when she was a kid, she would sort all of the cereal. And I'm like, I can tell.
Right.
So I feel that this very natural human behavior of organizing things into stacks is something that we've lost with AI. The ability to print out little cards and, you know, sort out the cards in the table as I'm sorting ideas in my head is something that is so natural. And I want to bring this back. And I think that the system that we have built, this Mantis system that I'd love to show you a demo of at some point, allows you to now take the human aspect back into data science. Can
people listening go to a website and check it out? What is it?
Just Google, actually go to mantisai.csale.mit.edu or withmantis.com.
Withmantis.com.
With
okay,
mantis.com.
that sounds
go
simpler.
there.
Okay.
And then you can, you know, click sign in. You'll immediately have access, and then you can start playing at alpha.withmantis.com.
Okay. But and this is the idea of like organizing.
The idea
that you were talking
is
about before.
we want a workbench. I don't want a visual thing where I'm sitting outside the glass. I want to enter and push things around and move ideas and sort of cluster them and organize them and circle them and, you know, ask questions about them. And I want this to transform the way we think about data, to make it much more human accessible, much more human centric, and much more enjoyable to just ask really hard questions that would take dedicated programmers in the span of milliseconds.
Yeah. Manolis Kellis, thanks so much. Thanks for letting us do this in your office.
Cara, thank you so much for being so adaptive, and thank you to the man behind the camera. It's been amazing.
Thank you. Thank you. I appreciate it.
And before we go here, if you want to check out Manolis's creation, Mantis, which you just heard him reference, you can head to our show notes. There, you will also find details on the 2025 slate of courses that CSAIL has coming up. I'm Kara Miller. The podcast is produced by Matt Purdy and Andrew Zukowski with help from Audrey Woods. Join us again next time and stay ahead of the curve.